Okay, you see my screen here? Yeah, can, good. Okay, so this topic is on forces. Um, you need to try to recall what you have done in primary school. Forces is not something that is foreign to you. You have already covered some of it in primary school. Okay, so what you learn in primary school is, as usual, like you are still going to recap all these in secondary school. Force is actually a push or a pull. Yeah, and then examples of pushes will be this, like kicking a ball, squeezing line, and then lifting the lid on the pot. Look at the actions. Then lifting the pail of the well. These are examples of pull. So you know what are pushes and what are pulls. Okay. So these are examples of the forces. You also need to understand sometimes there's a combination of a pull and a push. Okay, like this particular example here. Okay, effects of forces. This is also something that is not new to you. Okay, you cannot see a force, but you can see the effects. Okay, so a force can actually cause stationary object to move. It can stop a moving object. Okay, it can change the size and shape of an object. It can change the speed of a moving object. So I'm not going to go through all these again because you have done all these in primary school. Do you still recall what you have learned? Yes or no? All of you. I think important, Harvard, you say no. Don't remember all these. But when I go through this, do you recall now? Yeah. So all these, you will have the notes so you can actually read through them. I hope you have already watched the videos in the e-learning portal. It will actually kind of help a bit lah. Okay, you have already read your textbooks also, right? Okay, so now, if you go through again, a stationary object starts moving. Okay, so like, for example, a trolley, it is actually not moving initially. Then you give it a push, it starts to move. Then you can also stop a moving object. In this example, it is like playing soccer when the ball is coming to you and then you're the goalkeeper, you need to stop the ball, right? Yeah, so this is the example. Then changing the size and the shape. Take note, you can only change the size and the shape, but you cannot change the mass, right? Forces cannot change the mass of any object. The mass will stay the same, even though it looked different. Okay, changing the speed, you can speed it up, you can slow it down. Okay, so in this case, for example, the ball is moving and then you still kick it, it will either speed it up, or if you are kicking the opposite direction, then you either slow it down or you change its direction of movement. Okay, so this is the one I'm talking about also. All right, change direction of movement. Tennis, badminton, this is what you do, even volleyball. Right, so the next example here, turning effect about a point called a pivot, right? So if we push a wheelbarrow, this is actually what will happen. The turning effect will actually help us to push it with lesser force. Okay, turning effect, it is not exactly tested in Sec 2. Okay, so this is not one area of focus, but work done, we will be talking about it. Okay, but not today's lesson. Now, today's lesson, I think, is more like a recap of what you have learned in primary school, plus a little bit more for Sec 2. Okay, take note here, when all forces acting on an object are balanced, the object will not move. Okay, so these two guys are trying to push this block. They must be exerting the same force, right? So that's why the object stays stationary. Types of forces. Now you need to know this. Okay, contact forces, non-contact forces. We don't use these terms in primary school. Okay, but the word contact and non-contact, I think is pretty obvious what they mean. Okay, so contact forces will include things like friction. Yeah, so the surfaces are actually in contact, right? And then air resistance. Yeah, air resistance really come in touch with, come into contact with the whatever matter it is actually going against, right? And then elastic force. Okay, so all these are contact forces. Non-contact forces, so they can just exist on its own, like gravitational force. Okay, it's kind of a pool. There's no contact. Okay, no matter where we are, okay, whether we are jumping up or we are sitting down, there's always this gravitational force acting on us. Okay, then magnetic force also. All right, you don't need them to come into contact for the force to be there. So over here, okay, if we go into friction, now, friction is something that you have learned already in primary school. Okay, it's a force that opposes motion. Okay, you will be required to answer in a clearer manner. Okay, not just a force that opposes motion between two surfaces in contact. It will be relevant for you to actually write this down. It can either slow down or stop the movement of an object. This one we know. Okay, so prevent stationary objects from starting to move when other forces act on them. Yep, so that's how we can actually have our, let's say, our bottle staying on the table. Yeah, a gentle push doesn't cause the bottle to topple over, things like this. So rougher surface will produce more friction. Okay, this is something we know. Now, we also know that friction can be useful, it can be harmful. So examples of how it is actually useful to us, for example, I can grip onto this marker or this pen easily without dropping it. Okay, you can drive a car without skidding. You can actually put a brake, okay, to your bicycle, to your car, yeah, or any moving vehicles. You can walk without slipping also. So these are quite common and you have already learned them. Now, friction can also be a nuisance because it causes wear and tear. It causes a lot of heat to be generated. Machines can overheat due to that. Okay, so they can wear out faster. Then car tires, because of the friction with the road surface, okay, it causes the tire to be worn out, and that can lead to accidents. It also leads to the sole of the shoes to wear out. So if you find that when you're walking, let's say on a wet ground and it's slippery, it's time to change your shoes because the soles are already worn out. It can cause you to fall easily. Now, friction also slows things down. So when there is more friction, you will need more energy to overcome the frictional force for the object to move. Okay? To reduce friction, this is what you can do. Apply lubricants, okay, such as oil and grease. It can be wax as well. Then put rollers, put wheels, put ball bearings. Do you still remember all these things, Harvard? Can recall all this now, Yeah. Okay, so air resistance. Maybe this is something that you hardly talk about or talked briefly with your teacher in school. Okay, so air resistance is something that we will study more in secondary school. Okay, it's a form of friction between falling objects and the air. Air is made up of a lot of particles. All right, so all these particles leads to the friction. We call it the air resistance when objects are actually moving from the top to the bottom. So it will slow down the fall, okay, of the moving object. It can slow down a falling parachute, okay, by acting against gravity. So air resistance also acts against aeroplane as well as the birds. So you notice that bodies of aeroplanes and birds are streamlined. So this word here, streamline, is important, okay? You must use this word to help you answer questions. Okay, so they can glide in the air, they can move easily through the air. So elastic force, we talk about elastic force as well. So that is actually the force acting on a stretch or a compressed elastic object. Okay, it will allow it to return to the original shape or length. Something that we learn as well, we talk about the spring, we talk about the rubber bands, etc. Now, elastic force actually acts in the opposite direction to motion, so it will resist the change in shape. All right. Then the further the material is stretched or compressed, the greater the elastic force. Once the stretching or compressing force is released, elastic force will let the material go back to the original shape. So this is something that we are also familiar with. Okay. So they gave an example of the bungee jumper. Okay, this is the scary thing. I don't like to look at people doing this activity because I always worry, that, this elastic or the bungee cord will actually break. Yeah. Or they don't estimate the length properly. So I've seen videos where accidents happen. All right. And then the person didn't come to a stop, actually landed all the way to the ground. Very scary video to watch. Okay, so we talk about the non-contact forces. Now, gravitational force, I think I'm not going to read line by line. You are going to fall asleep, if I do that. Okay, but gravitational force, important thing you need to know. Okay, it is not just about a pulling force, pulling everything down to Earth. Gravitational force is the force that attracts two objects with masses. You're going to learn more about this in Sec 3. Okay, so Sec 2 is not that detailed. You don't have to explain so much. Okay, you just need to know that it's actually a force that's acting between two objects with masses. So they actually pull towards each other. There's a kind of attraction. Now, when you talk about weight, are you all familiar with weight? You know about the difference between mass and weight? Yeah, so Harvard, tell me something about mass and weight. You can also share examples. Okay, so mass is the measure of the amount of matter, right, in an object. Yeah. Weight's definition is shown on my screen. Yes, correct. So what is weight? Okay, weight is actually a measure of the gravitational force acting on an object. Right, so the heavier the object, the greater is the force of gravity acting on it. Okay, your mass will not change. I think your teacher shared with you when you were in primary school, talking about Earth as well as the moon. If you're on Earth, this is your mass, this is going to be the weight. For example, let's say if you are, 50 kg, that's the mass, right? Then your weight on Earth is going to be 500. Do you all know that? Okay, because the pull of gravity, okay, the gravitational field strength is about 10. Okay, so you always multiply by 10. Now, when you are on the moon, okay, let's say you are 50 kg. Okay, so on Earth, your mass is 50 kg, your weight will be 500 newtons. When you're on the moon, your mass stays the same because it's about how much is inside you, right? Yeah, so it's a measure of how much matter inside you. So you are going to stay the same. But because the gravitational pull on the moon is weaker, okay, weaker by 6 times. So 1/6 of the original. So you need to actually take this 500 divided by 6, and that will be the weight of this person on the moon. If you are on another planet, it will really depend on what is that gravitational field strength of that planet. Then you can calculate the weight. Is that okay? But your mass will stay the same throughout. All right, Janelle, okay not? Janelle? Okay, Zenith is your sister. She also took lessons with us last year. Ah, okay. I think I remember her. Yeah, Sec 2 last year. So she's in Sec 3 now. Do you know we offer Sec 3 classes also? So if she's interested, did she sign up? There is mathematics, there is also pure chemistry and pure physics. Let your sister know. I think Chinese as well. Okay, let me see. Okay. Jeremy. All right, let's continue. Okay, so gravitational pull depends on the mass and the size of the object. I think that is also something that we talk about. So you see here, The moon is smaller, so lesser gravitational pull. So the weight